Hey everyone, good morning, good evening, good afternoon. So in this video, we will go through what happens, obviously a little bit visually, between your server and between the web browser about HTTPS, even though I'm using HTTP, but this diagram, this image, we want to use so that your foundation of, say you visit Amazon.com, you will clearly see you are doing HTTPS colon double slash www.amazon.com. So what is that HTTPS about? It's a small word. And then let's see what is going under the hood. So first of all, on the left side, so this is TLS architecture diagram. On the left side, let's focus on this box. So you'll see browser, user, client. It can be any browser, all works the same way. Say it is example.com, whatever, any site. And then we have the browser is running on a host like on my Mac or your Windows or anyone other's Mac or Linux. And then it has access to the operating system. Okay. And the operating system has pre-installed root certificate and other trusted root CS. What is a root certificate? Let me give you an example. Say you go to a bank and you want to open an account, and the bank, the customer service that is helping you open an account will ask for an identity document from you. And you will hand over your driving license or your passport, and the bank has enough electronic equipment to scan the barcode in your passport or in your driving license and get that verified electronically. But when you scan a passport in an airport or in a bank, it goes to the State Department of the passport issuing authority, and they have electronic server to authorize that authorization request to tell whether the passport is valid or not, fake or not. And the same for driving license. That driving license goes to the State Department of Motor Vehicles and then gets approved, gets checked. Root CS, those are these driving license and passport are about approving the identity of a human. Whereas certificates, X509 certificate, that's what they're called, they are about to verify the identity of a web server. That my browser can trust that a web server it is interacting with for going to Amazon.com is literally authentically owned by the Amazon company. How that will be proved? Because the Amazon.com web server will present a certificate to the browser that the browser can trust. How the browser will trust? So browser knows how to go to an independent party which is already installed in its operating system and present the same Amazon certificate and get it verified. The other certificate that your browser is consulting or delegating the validification of the Amazon.com certificate is called the root CA. Root certificate or the CA stands for certificate authority. Like your passport issuing department, like US State Department or the Department of Motor Vehicles in the state, are the certificate authority. They issue certificate, they issue driving license. In this case, whoever issued that certificate can verify it is valid. So how it works, if you come down a little here, the root CAs are too far away. So root CAs do not validate every certificate. Root CAs create other intermediate CAs for issuing certificates. And browsers are able to, this is called the certificate chain. Then the intermediate CAs, I know one company, Let's Encrypt, is another intermediate. These are intermediate CAs. VeriSign is a root CA. So these guys, Google probably will be able to issue a certificate to a website running on Google Cloud. So the browsers that we have on our machines is able to both validate the intermediate CA certificate and the root certificate because the root certificate is already installed on the operating system. So so how it works, a root certificate, VeriSign is issuing an intermediate CA to say Amazon.com or AWS, Amazon Web Service, and Amazon Web Service is issuing a certificate to the Amazon.com website. So that is the certificate chain. Okay. And let's see. Now, here in this case, once this browser and certificate chains are clear, what we will do is to see the sequence of calls. The browser will first initiate a call to the server and say client hello. And the server will respond with a server hello. And at that same time, third call, the server will send the certificate that is a public certificate. Then four, the browser validated certificate using the certificate it has got installed on it locally. Browser verifies the domain name and certificate validity 4 and 5. Then 6, server proves possession of private key. Server says another call to convince the browser that it has the secret key. It has the secret key that it will use to encrypt the shared key. Remember, we talked about symmetric encryption is extremely fast, and the shared key is exchanged between the server and the browser through PKI or public key infrastructure. So once the server says number 6, server proves possession of private key, then the shared session key is established at the 7, because as I said, if you remember public private key, it is very easy, unbreakable. Then the encrypted information started going. Okay, this is TLS, and what it proves on the other side, it is using public key cryptography, private key status secret, stays secret, digital signature by the certificate authority, browser trust store has the certificate of the root CA. It is confidential. That is why confidentiality is there. It is encryption, and then integrity is what we covered in digital signature, and authentication is you can trust your the certificate root chain that the server certificate that you are seeing is an authentic one. That's where we would stop and move on to other videos. In this video, what we discussed is a foundational skill that you guys will face from years to come. So this is something where you also will make sure that if you pay attention to this, a lot of people do not learn things in this detail. So please subscribe if you like. Please share, and please press the bell icon to subscribe. And I will see you in the next video. Thanks for listening. Have a great day. Bye.